Hey everyone! Today we are diving into the fascinating world of probability. Whether you are preparing for the exams like the IMAT or just want to boost your math skills, this session is perfect for you. I'll be walking you through intermediate level probability concepts and solving some challenging MCQs. And guess what? Stick around till the end because I have an exciting announcement about a special prize you can win. Let's get started. First, a quick recap of the basics. Probability is simply the measure of how likely an event is to happen. So, if you know the formula, probability of event is equals to number of favorable outcomes divided by total number of possible outcomes. For example, if I roll a dice, the probability of rolling a 4 is 1 out of 6, right? Because only one face of the dice shows a 4 and there are 6 total faces of the dice, right? Now let's level up. Probability gets more interesting when we talk about events. There are two types of events: independent events and dependent events. Now we will move to the independent events. These are the events when the outcome of one doesn't affect the other. For example, rolling a die and flipping a coin are independent events. Let's move on to the example. What is the probability of rolling a 3 on a die and flipping a heads on the coin? Right? So we will multiply the possibilities. It becomes 1 by 6 because a dice which contains 3 has one face. So it becomes 1 and the total is 6, and the other event is flipping a head. Head has one face and coin has total 2 faces. When we multiply them, it becomes 1 by 12. So now we will move to the next question. Now we are talking about dependent events, right? So what are dependent events? Two events are dependent if the outcome of one affect the outcome of other. For example, if you draw two cards from a deck without replacement, what is the probability that changes for the second card because the first card is already removed? Let's calculate. So first card is equal 26 by 52. Let me erase it and write it again. 26 by 52. This is the probability of first card. Now draw the second card. When you have already drawn the first card, so the left out becomes 25 out of 51. Now according to formula, we will multiply these values. So probability is equal 26 out of 52 multiply by 25 out of 51. When you multiply them, you will get answer 25 out of 102, I think. Yeah, 102. So see how the probabilities change in dependent events. Now we are talking about the rules of probability. There are 5 rules of probability: the AND rule, which we call multiplication rule; the OR rule, which we call addition rule; conditional probability; the complementary rule; and the probability with combinations. Now let's tackle these rules. The first is the A and D rule, which is also we called multiplication rule. Use this when you want to find the probability of two events happening at the same time. Multiply their probabilities. So the formula of AND rule is probability of A and B is equals to probability of A multiplied by probability of B. Now we will move on to the example. You roll a fair dice and flip a coin. What is the probability of rolling a 5 and flipping a head? Right? So after applying the formula, probability of 5 and tails means heads, 5 and heads is equals to 1 by 6 multiplied by 1 by 2. So we will get the answer is 1 by 12. See, these questions are very easy. Now we are talking about the OR rule. Now the second rule is OR rule, which we also call the addition rule. Use this to find the probability of either one of two events happening. It could be mutually exclusive events or not exclusive events. So we add the probabilities of the individual events. So if you see the formula, the probability of A or B is equals to probability of A plus probability of B. So now we will move on to the example, which is mutually exclusive example. Example number 1. What if you roll a dice? What is the probability of getting a 2 or 4? So if you solve this, probability of 2 or 4 is equals to 1 by 6 plus 1 by 6. After solving, it becomes 2 over 6. After cutting this value, 1 and 2 and 2 3 times 6. The answer is 1 out of 3. Easy so far. Let's move on to the next question example. I think this is the next example. Let me erase this. Example number 2. Not mutually exclusive. So in question, they are asking a deck of cards has 4 kings and 13 hearts. What is the probability of drawing a king or a heart? So probability of king or heart is equals to probability of king. Because you see there is an overlap, you have to subtract this. Probability of king plus probability of heart, minus probability of king and heart. So this is the formula: probability of king plus probability of heart minus probability of king and heart. So if you apply this formula, so it becomes 4 by 52. If you see in the question, 4 kings and total 52 cards plus we are 13 hearts by 52 minus 1. King and heart, 52. You will get 16 out of 52. If you cut these values, so you will get 4 out of 13. Now let's move on to the next rule. About the next rule, which is conditional probability rule. This is the probability of an event happening given that another event has already occurred. The formula of probability is probability of A of B is equals to probability of A and B out of probability P into B. So where P into A of B is the probability of A happening given that B has already happened. I will give you the example in the MCQs because this contain a long steps. So we will move on to the, just memorize this formula and we will move on to the next rule, which is the complementary rule. The complement of an event is the event that even doesn't happen. So the formula of probability of not A is equals to 1 minus probability of A. If you see the example, the probability of it raining today is 0.3. Then the probability of it not raining is what? Right? So if you see the formula, probability of not rain is equal rain is equal 1 minus the probability of A, 0.3. So it becomes 0.7, right? So now move on to the next rule, which is probability with combination. Now we are talking about the probability with combinations. We also call this combinatorics, right? So in some problems you may need to calculate probabilities involving combinations. For example, drawing multiple cards or choosing several items. When you have multiple objects and you want to know how many ways you can select a subset, you see combinations. So the formula for combination, the number of ways to choose R items from n items is n. This is a binomial fraction R, and the binomial fraction into n minus R. So in example, how many ways can you choose 2 cards from a deck of 52? So if you see the formula of the above, 52 is n, which is 52, and n is the, from the n item is 2, which are 2 cards, is equal. So if you see, the n is 52 multiply by 51 divided by 2 multiply by 1. It becomes 1326. So these are the